Hello everyone, so welcome back again, and the topic for the day is load balancing in EIGRP. Okay, so basically in the load balancing, first of all, we will calculate the route metric for each and every path for the destination. Then we will calculate the route metric and compare them. Okay, if the route metric of both the path, like this is our source and this is our destination, and if the route metric for both the path are equal, then the load balancing will be there. Load balancing. Okay. So, what is the meaning of load balancing? That both the path will be used to transfer the data. In rough, you can say that 50% data will be forwarded through the path number one and 50% data will be forwarded through the path number two. This is called load balancing. Okay. So, first of all, we are going to do the configuration of EIGRP on this network. Then we will find the route metric for both the paths. Okay. So, I already have provided the IP address on this network. So, let's start with router number one. Okay. So, let me show you the IP address configure terminal. So, do show IP route. So, you can see that IP address is provided. Do show IP interface brief, but the routing table doesn't have the destination IP addresses. That is means destination network is not available in the routing table. That is means the routing is not done yet. Okay, now I already have provided the IP address to this network. Now it's time to do the configuration of EIGRP on this network. Okay, so let's start from router number one. So there are two networks on router number one. So go to global configuration mode and let's do the configuration of EIGRP. Router EIGRP 1 network, that is 192.168.10.0. Another network is 192.168.11.0. So I have provided all the network information. Let's go to router number 2 and do the configuration. Configure terminal router EIGRP1 network 192.168.10.0 network 192.168.12.0. Okay, let's go to router number 3 and also do the configuration of EIGRP. So as we can see that there are three networks over router number 3: 192.168.12.2, 10.0.1.0, 192.168.13.2. Let's configure the EIGRP on this network. So router EIGRP1 network 192.168.12.0, network 192.168.13.0, and network that is 10.0.1.0. So I have configured all the three networks on EIGRP router number 3. Let's go to router number 4. Okay. So configure terminal router EIGRP1 network 192.168.11.0 network that is 192.168.13.0. So soon I am going to get the message for the adjacency. Here I got it. All the adjacency messages. That is means the EIGRP is properly configured on all the routers. Okay. Now let's go to router number 1 and check the routing table. As I told you that this one is source and R3 is the destination. Basically, this loopback will be considered as the destination, that is 10.0.1.1. Okay, so to highlight that this is a loopback IP address, let me draw a line over here. So this is a loopback IP address. Okay, so we must also consider this IP as separate interface. Okay, in calculation of route matrix. So first of all, I will observe that in between R1 and R3 which one is the best path. Okay. So let me observe that via routing table. So let's go to router number one and check the table. Do show, do show IP route. Okay. So here we can see that to reach the network 10.0.1.0, we have two different pathways. 192.168.11.2 and 192.168.10.2. So there are two different paths to reach that. Okay. So here we can see that 192.168.10.2 is over here and 192.168.11.2 is over here. Okay. So both of these are can be seen in the routing table via R1. Okay. Now the question is that how both the paths will be selected. Okay. The path is selected via route metric. Route metric. Okay. So how to find the route metric for the same? Okay. So to find the route metric of an interface, how we can do that? So let's start with router number one. Okay. So we have to find via interface to interface. Okay. So show interface F0/0 separator section DLY. So here we can see that the bandwidth is 100K, delay is 100 microsecond. So let's mention that bandwidth 100K and delay is 100 microsecond. Okay. 100 microsecond. In the same way, because this is also fast Ethernet port, so the delay and bandwidth will be the same. Okay. But in router number three, it will be different because this is a loopback interface. Okay. So let's observe that. Go to router number three. Okay. So do show interface loopback one. Do show interface loopback one separator pipe section DLY. Oh, sorry. Show interface loopback one. So it is 8000K. Okay. And delay is 5000 microsecond. Let's mention this. Okay. So bandwidth is 8000K and delay will be 5000 microsec. So now we are going to calculate, as we can see that the same interfaces are available over here. So delay and bandwidth will remain same over this end also. Okay. Here we got it. Now, what is next dear? First of all, you have to calculate the delay and bandwidth for the same. Okay. Now let's find the route metric of route number one or path number one, then path number two. Okay. How to calculate this route metric? Let me take the screenshot for the same. Okay, snipping tool. So let me take the screenshot because we have to do some calculation over here. Copy. Let me open in Paint. Okay. Here we are going to do the calculations. Okay. So this is my network. Let's do the calculation over here. So dear, first of all, we will find the total delay for the path. So total delay will be equal to 5200, and least bandwidth can be 100K. Okay. So according to these two factors, we are going to find the route metric of path number one. So route metric of path number one for path number one. Okay, what is the formula for the route metric? So cumulative delay plus cumulative bandwidth multiply by 256. So first of all, let's find the cumulative delay. Cumulative delay is is 5200 divided by 10, that is equal to 520, and cumulative bandwidth, that will be equal to 10 to the power 7 divided by the least bandwidth, that is 10 to the power 5, that is 100. Okay. Now, according to both the value, let's find that. So route metric will be equal to, that is 520 plus 100 multiplied by 256. So that will be equal to what? 620 multiplied by 256. So let's find the values. So in calculator, let's 520 multiplied by 256, that is equal to 133120. No, it's 620 actually. So 620 multiplied by 256, that is 158720. Okay. So as we have find the route metric for the path number one is route metric is 158720. As we can see that all the factors remain same on the path number 2 also. So the route metric will remain same for the path number 2. The rule says that if the two paths having the same route metric, so rule says that if two paths having the same route metric, that is means both path will can be used for the will be used as the best path. Okay, so according to this network, path number 1 and path number 2 are having the same route metric. If they are having the same route metric, that it means both path will be selected as the best path, and here according to this the load balancing will be done. That it means 50% data will be forwarded through this side and 50% data will be forwarded through this side. This is called load balancing, and the load balancing will be done on the behalf of this route metric values. So let me also show you in the routing table what are the values over here. So let's go to router number 1, and in the routing table you can see that 158720 is the route metric for both the paths. So that is why both path will be selected as the best path. So dear, this is what we call load balancing in EIGRP. If you have any confusion, you can ask me in the comments. Have a nice day.